And 6 through 8. Which of the following represents the alternative hypothesis for a two-tailed test?
That is not the not equal to sign.
Okay.
And for the left tail.
Oh, is it me?
Yeah.
Okay. Which of the following represents the alternative hypothesis for a left-tailed test?
I would say the first one.
Yeah, it's less than.
Mm-hmm.
Because what is the tailed thing? Is that like a skewed?
I just looked up I'm under where it talks about that in the reading, and it says it right here. I don't know why it's like that, but it says it right here.
I see it. I think I see what you're talking about, but I don't really know what that means.
Yeah.
So basically, it's like you're creating a new hypothesis for the alternative hypothesis.
Uh-huh.
So the left-tailed is, so if you have the bell-shaped curve and you shade the far left tail on the other side of the z-score, so it's like what is the probability that it's going to be less than it, you know what I mean? And then so right-tailed would be the opposite, so
Okay.
and then the two-tailed is if it's just straight out not equal to, then it's when you shade both sides.
Okay, that makes sense. Thank you.
Mm-hmm. So which of the following represents the alternative hypothesis for a right-tailed test? That'll be the second one.
Yeah. Be greater than. Okay. The outcome of a hypothesis test is determined by comparing the p-value to the level of significance, or whatever that is. Use the information for questions 9 through 10. Which relationship would result in failing to reject the null hypothesis?
Wait.
What?
Yeah, come on.
Failing to reject. Is that like a double negative? So you're accepting the null hypothesis? Or
Yeah, that would be your. Yeah. So yeah, you would agree with the null hypothesis.
So significant. I would say the first one. No. It's the first or the second one.
Yeah, I don't even know what Z is, so where the heck did we get that? So.
yeah, sorry, I feel a little unprepared. Feeling right. So which one did you say? The first one? I forgot.
It was either the first or second one.
Yeah.
That.
We don't know.
We're in lesson 9, right?
Yeah.
Okay.
Makes sense.
Okay, so it says if the p-value is low, reject the null.
So then alpha would have to be greater than the p-value. So it's the second one. And then to accept it, it's the first one.
Okay.
I mean, so if we reject the null hypothesis, then the p-value is greater than alpha.
Yeah, that sounds right.
Oh, because so the p-value is just a fancy word for saying the value in question, kind of.
So that one's like the probability.
Oh.
Yeah, it says if p-value is less than alpha, we reject the null hypothesis. So, yeah.
This is confusing.
So, if we fail to reject it, then the p-value is greater than alpha. So,
So is the first one?
I think it's the first one because I'm reading under the level of significance and it says if the p-value is less than alpha, we reject the null hypothesis. Conversely, if the p-value is greater than alpha, we fail to reject it. Yeah, so p-value would be greater because we fail to reject the null hypothesis.
Okay. Is that 4.4?
But yeah, it's going to be p-value is greater.
And then 10. So if we reject the null hypothesis, then p-value is less than alpha.
Yeah.
So it's the first one who greater than?
Yeah, the first one's greater. P-value is greater than alpha, and then p-value is less than alpha is number 10.
Yeah.
Makes sense?
Yeah. Okay. So it's my turn, right?
Yeah.
I think so.
Which relationship would result in rejecting the null hypothesis? It's not asking like the same question.
So that one we said was less
it's
than p-value.
Okay. So it's this B.
Yeah.
Mm-hmm.
Awesome.
Cool. Is it my turn?
Yeah.
Okay. An insurance company is reviewing its current policy rates. When originally setting the rates, they believed that the average claim was about $1,500. They were concerned that the true mean is actually higher than this. Use this information for questions 11 through 12. So which of the following would be an appropriate alternative hypothesis? So the average claim is greater than 1,500.
Yeah.
Yeah.
Okay.
Okay. Which of the following would be appropriate null hypothesis for HO?
The first one, right?
Mm-hmm.
Yeah.
The insurance company randomly selects 40 claims and calculates the sample mean of X equals 1,650. Use this information for every question. The insurance company assumes the distribution of the sample mean is normal. Is this a good assumption? What's the number that it's supposed to be normal? Is that
30.
20? Oh,
30.
okay. So yes.
Yeah.
Yeah. It's a law of large numbers for the theorem.
All right.
Which of the following is the test statistic as defined in this lesson? X, I believe.
Yeah, X, you say X.
Mm-hmm.
Yeah. That's what I think. Right.
Yeah. So my turn now?
Mm-hmm.
Okay. The historical mean of sales receipts at a grocery store is $150 with standard deviation of 40. The store manager suspects the average has decreased. She sets a hypothesis test with the following hypothesis. Okay, those numbers. She will use the level of significance of alpha equals 0.05. She then takes a simple random sample of 36 sales receipts from her store and computes X equals $144. Use this information for questions 16 through 18. What is the z-score associated with the test? Round to 3 decimal places.
Sorry, I just found the answer. I just found the 15 is Z. Since we use the z-score to determine if X is far from the assumed value. This is called the test statistic.
So does Z stand for z-score?
Yeah.
Okay.
Sorry.
And that is the test, that thing?
Yeah, that's what it That's what it says.
Okay.
And then it has an equation. Yeah. So, which is what you're looking at before. So I'm guessing
Okay.
we're going to use that for this.
So, okay.
X minus
144. Over.
Okay. So 50 minus.
Where's the calculator?
I can't find mine.
Calculator?
Yeah.
Yeah, me neither. Me and my husband share it. Well, technically this is my husband's desk. And he moves. I tend to leave my stuff.
Did for the test just yesterday, but it's not on my desk anymore, so I don't know where it's at.
This wasn't due yesterday, was it?
Yeah.
Yeah, it was. Yeah.
I thought it was due Saturday.
I think it was due yesterday. I would try taking it still.
Yeah, definitely try and take that like right after this.
Whoa, thank you for telling me that. That would be really bad. Okay. It says due tonight, so great. I will do that after this. I was putting it off because I don't want to do it. Oh, where did it go?
Got it.
I can't use my phone because it doesn't have a...
I'm getting a really weird number.
Okay. Did you do the... For the... I think we have to do the standard deviation divided by the n on it too. Yeah, wait, hold on. Here. Did you see that calculator I had on the desk? Oh, okay. Thank you. Bye. Okay. Okay. Z squared. X. Well. X.
Yeah, I think I'm doing something wrong too, because I got 720.
Okay.
You got 720. I got 758. So I'm like, I don't know what this is doing.
Okay. Okay, so I'm doing 144 minus 150 divided by 40 times the square root of...
Oh, never mind. I see what I was doing wrong already.
86. Okay. I got 143.37.
Okay, 1 second. 1 second.
What'd you say you got, Emily?
I got 143.375.
Okay. Yeah, I was using the wrong numbers. As you were saying, I was like, oh, that's right. There's why I went wrong.
Okay.
What did you get?
143.375.
Nope. Okay, well, how did you do it?
I did, so I used, so X is 144 minus the mean, which is 150, divided by the standard deviation 40, divided by the square root of n, which is 36.
I got negative 0.9.
Yeah, that's what I got too when I put it in my calculator.
Really?
Yeah.
Yeah.
Did you remember to put parentheses?
Yeah, maybe. I was just thinking, oops. Okay, then I got negative 0.025.
What? What in the world?
Let me put more parentheses. This is retarded. Not again. What did you guys got? 9?
Yeah, I got negative 0.9.
Negative 0.9.
Negative 0.9. 144 minus 50 is 150.
So less than.
40 times. Oh, I put times. Yeah,
that makes sense now.
okay, yeah. Negative 0.9. Okay. Yay, I'm retired.
Good.
Okay. Good thing. What inference would you make about the null hypothesis from this problem?
I think we skipped number 17.
Oh, no, we just do that one?
No, we did.
No. Yeah, it is.
Oh my gosh. What is the p-value associated with the z-score from the previous question?
So that's when you shade the left side. Because it's less than the alternative hypothesis. Yeah. So in the applet, then you would shade the left side. And I got 1.184.
Can you put the applet link in this thing for me? In the chat? What did you put in the applet?
0.9.
Oh, okay. Do you mind putting the link to the applet? Oh, sorry.
Did you get it?
Yes.
Perfect.
Point. So you would shade the left,
Mm-hmm.
then 0.184.
That's what I got.
What's the question?
So what inference would you make about the null hypothesis for this problem? Hang on. So let's look at it.
That it was.
It is less than, so p-value is less than alpha. So reject the null hypothesis.
Yes.
Sorry, I'm. So how did you know what?
Greater than the z-score. Because the z-score is negative and the p-value is positive. Right? We got negative 0.9 for the z-score, correct?
Yeah.
Okay. So then.
Yeah.
How did you know what part to shade?
Because so the alternative hypothesis is saying that the new mean is going to be less than 150.
Right. Yeah. Okay.
So then you shade the left side.
Okay.
The videos actually did a really good job because I didn't read it all.
Okay. Yeah.
And I think number 18 is actually failed to reject the null hypothesis. Or wait. No. Yeah. No. Never mind, you're right. Yeah, it says reject the null hypothesis.
Wait, so what are we thinking the answer is?
So we reject the null hypothesis.
Is yeah. Or so I actually think it's failed to reject because the p-value is greater than that, right?
Then we would have gotten the. So did we do the other ones backwards then? 9 and 10.
No, because the p-value is greater right here, right? Yeah, and so we.
Oh, it is greater. Oh my gosh, I was looking at the wrong digits. I'm retarded.
So it's failed to reject the null hypothesis.
Yep, you're right.
I'm so confused. No. Okay.
Don't worry, I'm kind of confused too. We're banking off you on this degree.
Okay.
Okay, are we ready to move on, or just
Yeah.
making sure I don't want to move on if we're still talking about it. Okay, there are two types of errors that can be made when performing a hypothesis test. Which one involves rejecting the null hypothesis when the null hypothesis is true? What?
So I don't remember which one it is. So it's either. So the first error you can make is rejecting it when it's true, and the other one is not rejecting it when it's not true. Does that make sense?
Yeah. Let me find.
I think it's type 1, but I'm not 100% sure.
Okay.
Okay, here we go. Type 1 and type 2 errors. Type 1 error, whenever we reject a true null hypothesis, we say that a type 1 error was committed. Where's type 2?
So it's type 1 then, right?
Yeah.
Okay.
That's what I think. I don't see anywhere where it says what type 2 is.
Yeah, me neither. I just know that type 1 just said that, so.
Type 2 is just the opposite. So if so rejecting the null hypothesis when the null hypothesis is true is a type 1, and so a type 2 is not rejecting it when it's false.
Okay.
Okay. Cool.
So
Is it my turn?
I think it might be my, I don't know. I think it matters.
Nope, it doesn't.
Okay, a researcher decided that instead of using a level of significance of alpha equals 0.05, he will use alpha equals 0.01. Which of the following will be true? The probability of type 1 will increase, probability of type 2 will increase, probability that the null hypothesis is true will decrease. His experiment will be more scientifically valid. I think type 1? I don't know. That's kind of a confusing question.
Yeah, I don't even know what it's really asking.
I think, actually,
I think it's the third one. The probability that the null hypothesis is true will decrease because he just changed the numbers. So how could he be right?
Oh man, that's a weird question. All right, I'm just gonna pick one. I kind of think it's type 2. I don't know. We'll find out.
I put the third one. So why do you think it's type 2? Let's see.
Because it's like it's so hard to get out of my brain, but it like kind of makes sense in my head. So if he's going to fail to reject the null hypothesis, right? That's what we decided. And then, so failing to reject it when it's false is a type 2. So that, and changing it from 0.05 to 0.01. Because what was the p-value? 184? I don't know. It's all like twisted and backwards and stuff. It doesn't make sense to me.
I found something that has both those numbers. Should I read it? It says we choose alpha to be some small number so that the probability of committing a type 1 error is low. The most common value for alpha is alpha equals 0.05. This is equal to 1/20. So when the null hypothesis is true, there is a 1 in 20 chance that it will be rejected at the 0.05 level of significance. Other common choices, other common choices include alpha equals 0.1 or alpha equals 0.01. That just makes sense to me.
Because it said, so the probability of type 1 error will decrease, is what it said, right?
Yeah.
So then the probability of committing a type 2 will increase.
Okay.
Okay, I'm down for that.
Okay. There. Ooh, they said it a lot better than I could.
So, if alpha is 0.05, compute the probability of committing a type 1 error.
Ooh, I think I know how to find this. Maybe. Let me try something.
How do you even begin to compute that?
Don't know.
I'm not looking forward to the homework.
I know. How was the test? Was it like the? Was
I
it
got
like
an 84
practice?
of it. It took me a while. I got an 84.
Sweet.
I don't know how I did so bad. Because we killed it on the review.
Yeah, we did good. Was it kind of like the review? I'm not seeking for like questions. I'm just curious if it was like the review.
Oh, yeah.
Sometimes our group meetings are not the same as our homework.
Yeah, it was fun. I didn't like the review. If you know the review pretty well, you should do fine.
Yeah.
And is it open book?
You get a page of notes.
Page of notes.
That's what it said. So really, honesty.
Yeah, who's gonna write?
Yeah, you need to be
I mean,
on your honor.
Technically, if this is an online school, I can make a page as small as I want, right? And then, so, okay, that's retarded.
how big is your page?
Well, I can just put it on Word and make it super tiny, and then. Anyway. Okay, sorry. I'm still.
Oh, I think I got it. Maybe.
So how do you even, like, all I'm seeing is, like, the probability will increase, but it's not telling me how to find the probability.
So what I did is 144 minus 50 divided by the quantity of 36 divided by square root of 5.
Where are you getting these numbers from?
From the previous info given.
It says it was only to question 18.
Yeah, that was only to 18, so
Oh, that what?
yeah.
Oh, then I have no idea.
Okay, I think it is 1/20. The most common value of A alpha equals 0.05. This is equal to 1/20. So there's a 1 in 20 chance that it will be rejected at the 0.05 level of significance.
So it's like the same number.
I'm gonna put it. I think that's it though.
Does the null hypothesis and the alternative
So what did you say for it?
Okay, you guys were both talking, so I don't know.
Sorry. What did you say for 21?
I said 1/20, but just because I read that
Oh yeah.
most common value for alpha is alpha equals 0.05, and then it says this is equal to 1/20. So then the null hypothesis is true. There's a 1 in 20 chance that it'll be rejected at the 0.05 level of significance.
So 0.05?
One in 20 chance.
Makes sense.
Okay. I'm good with that.
I can roll with it. Okay.
95%.
Oh, woo! Awesome.
And we missed one that should have been easy. Why did we miss that one?
Dang it.
What was? Oh. Nice. Well, I can go with this.
We get all the hard ones right, the easy ones we get wrong.
We're like.
Oh, it's just, okay.
Oh gosh.
I'll take it. I don't even care.
That's funny. Yep, I accept. All right.
Good job, guys. Good job.
Good job. Good teamwork.
All right. You guys have a good night.
You too.
Have
Bye.
a good
Bye.
weekend. Bye.
You too.